Here is a list of things you did before you turned 3. You worked out that the blurry shape making noise above you was a face, and then that it was one specific face, and then that this face was the most important object in the universe. You learned that things keep existing when you can't see them. You hauled yourself upright on a piece of furniture and fell down, and did it again the next day, several thousand times until walking became something you never think about. And you learned a language from nothing. No dictionary, no teacher, just sound coming at you all day until you cracked it. By your 3rd birthday, you were producing sentences you had never heard anyone say. That is the steepest learning curve of your entire life. Nothing afterwards comes close. You remember none of it. Not 1 second. There is a hole in your life roughly 3 years long. Everybody has one. And almost everybody assumes the same thing about it. That nothing was recorded. That babies are simply too undeveloped to make memories, so there is nothing to find. That assumption is wrong. Babies make memories, and in 2025, a team at Yale watched the machinery switch on inside a scanner. In animals, memories that looked completely gone have been switched back on years later. So the answer is not that the recording never happened. It's that the recording happened, and then something went wrong between the recording and you. I'll show you how we know, and flag exactly where the evidence stops and the guessing starts. Start with a psychologist named Carolyn Rovee-Collier and a piece of equipment you could build in an afternoon. A baby lies on its back in a cot. Above it hangs a mobile, the kind with little shapes dangling off it. A soft ribbon runs from the baby's ankle up to the mobile. When the baby kicks, the mobile dances. Babies work this out fast. 2-month-olds work it out. The kicking rate goes up sharply because kicking is now doing something, and a 2-month-old finds that extremely interesting. That gives you a memory test, which is the clever part. Come back days later, attach the ribbon, but leave it slack. So, kicking does nothing. Does the baby kick anyway? If it does, it remembers the rule. Rovee-Collier and her colleagues ran versions of this from the 1960s into the 1990s, and the numbers matter. At 2 months old, forgetting was complete somewhere between 1 and 3 days. At 3 months, 7 days. At 6 months, 14 days. So a pre-verbal infant can hold a specific learned association for 2 weeks. That alone should retire the idea that babies can't remember anything. But the result that actually matters for this video is the next one. Normally, after 8 days, a 3-month-old has lost the mobile rule completely. So the researchers, this is Rovee-Collier and Harlene Hayne in 1987, added one step. 24 hours before the test, they showed the baby the mobile and moved it themselves. The baby wasn't attached to it, wasn't kicking, wasn't doing anything, just watching. A reminder. Infants who got that reminder showed no forgetting at all. Not at 2 weeks, not at 4 weeks. On day 8, by every behavioral measure available, the memory was gone. And then a 2-minute glimpse of a dangling mobile brought it back intact. The memory hadn't been deleted on day 8. It had become unreachable, and a cue reached it. That distinction, gone versus unreachable, is the whole question. Everything that follows is scientists trying to answer it with better and better tools. The obvious next question is what's happening in the brain while this goes on? And for decades that was close to unanswerable, for a boring practical reason. Functional magnetic resonance imaging requires the subject to lie still inside a loud tube, and babies do not lie still inside loud tubes. They squirm and they cry, and squirming ruins the scan. A team at Yale spent years solving that as an engineering problem. Padding, timing, patience, attention holding. And in March of 2025, Tristan Yates, Nicholas Turk Brown, and their colleagues published the result in the journal Science. 26 babies, 4.2 to 24.9 months old, awake, not sedated, not asleep, in a scanner. The task was simple. Show the baby a stream of pictures it has never seen, faces, objects, scenes, while watching one specific structure, the hippocampus, the seahorse-shaped piece of tissue that sits deep in each temporal lobe and is required for laying down memories of specific events. Damage it in an adult, and that adult stops being able to form new memories of their own life. Then, later, test whether the baby recognizes those pictures. You can't ask a 1-year-old what it remembers, so you use the one honest signal a baby gives you for free, where it looks. Put a picture it has seen next to one it hasn't. Babies look longer at the familiar one. The finding. The harder a baby's hippocampus worked while it was first seeing an image, the more likely that baby was to look at that image afterwards. Brain activity at the moment of encoding predicted the memory, and it was carried almost entirely by the older half of the group. Under about a year, nothing reliable. Over it, a clear effect. The capacity to record a specific experience appears to come online somewhere around 9 to 12 months of age. That is a genuinely new thing to be able to say. Not that babies seem to remember, that we watched the machinery do the recording, and the recording predicted the recall. The author's own reading in the paper is that if the encoding hardware is running during a period we later lose completely, then whatever causes that loss is probably happening after encoding. Their phrase is post-encoding mechanisms. Memories from infancy becoming inaccessible for retrieval. Retrieval failure. Not recording failure. Now, the part that most versions of this story leave out and shouldn't. Look at the paper's own diagram of the experiment and you will find a label on the gap between seeing a picture and being tested on it. 20 to 100 seconds. Seconds, not years. That is all the experiment can speak to. It does not show that those memories survive to age 5 or 20 or 70. The researchers say so themselves. 2 possibilities are still on the table. Those memories may never make it into durable long-term storage at all, or they may persist and become unreachable. Turk Brown's early, unpublished work hints they might last until around age 3. Hints. So when you see a headline saying scientists have proved your baby memories are still in there, that is not what this paper shows, and its authors have not claimed it does. Which leaves the real question hanging. Has anyone ever actually gone back and found an old infant memory that looked gone? Yes. Just not in a human. In 2018, a team at the Hospital for Sick Children in Toronto, Axel Guskjolen, working with Sheena Jocelyn and Paul Franklin, published a study in Current Biology with a title that does not hedge: Recovery of Lost Infant Memories in Mice. The technique is called optogenetics, and it is one of the strangest tools in modern neuroscience. You genetically modify neurons so they produce a light-sensitive protein, in this case channel rhodopsin 2, originally borrowed from green algae. Neurons carrying it fire when you shine light on them, and you can arrange for the tag to install itself only in neurons that are firing during one particular window of time. So the cells busy at the moment of learning get marked, and their neighbors don't. Which means you can later switch that exact group back on with a pulse of light. That tagged group is what researchers call an engram, the physical trace of one particular memory in one particular brain. So, infant mice learned something specific, a place where something unpleasant happened. The neurons active during that learning were permanently tagged. Then the researchers waited, and the mice did what infant mice reliably do, which is forget. Put back in that place, they behaved as though they had never been there. Then the light went on. The mice froze, the standard rodent expression of, "I remember this place and it was bad." Reactivating that dentate gyrus ensemble was enough to bring the memory back. It worked up to 90 days after the original learning, which for a mouse is a very long time. The memory had not been erased. It was sitting there, intact enough to be triggered, with no working route to it from the outside. And it isn't only a laser that can do it. 2 years earlier, in 2016, Cristina Alberini's lab at New York University, Alessio Travaglia and colleagues publishing in Nature Neuroscience, had shown something closely related, and in a way, more startling. An experience a rat has during its infantile amnesia window is stored as what they call a latent memory trace. Latent, present, not expressed. And a later reminder, an ordinary cue, no genetic engineering required, reinstates it as a robust, specific, long-lasting memory, which is Rovee-Collier's dangling mobile again, 30 years on, with the biology filled in. Alberini's group also found the machinery underneath, and its shape is the interesting part. The window behaves like a developmental critical period, the same category of process as the window for binocular vision, or for absorbing the sound structure of a first language. A molecular switch flips as the young hippocampus matures, and the window closes. Nudge the chemistry of that switch after the animal has learned, and the infantile amnesia simply doesn't happen. The memory stays reachable. 2 lines of evidence then. In mice and rats, early memories that look gone are not gone. In human babies, the recording machinery is demonstrably running. Nobody has closed the gap between those 2 statements in a human being. That gap is real, and I am not going to paper over it. But it does reframe the question. The question stops being, why do babies fail to record? And becomes, why does a growing brain lose its own filing system? There is an answer to that, and it is not sinister. Nothing decided to erase your childhood. Your childhood was overwritten by construction work. Imagine rebuilding a library's shelving while the books are still on it. You are adding capacity. You are also unavoidably losing the ability to find a specific book. That is roughly what a baby's hippocampus is doing. New neurons keep appearing there throughout life. One of the very few places in the mammalian brain where that happens. And in infancy, the rate is enormous. Every one of them has to be wired into circuits that are already holding something. The proposal is that this is not free. Enough new wiring and you degrade what was already stored. That got tested in 2014 in Science by Catherine Akers, Paul Franklin, and colleagues. And they tested it in both directions, which is what makes it convincing. In adult mice, where neurogenesis is normally slow, they cranked it up after a memory had formed, partly just by letting the mice run, which reliably increases it. The adults forgot things they would otherwise have kept. In infant mice, where the rate is naturally high and forgetting is rapid, they turned neurogenesis down after a memory had formed. The infants held onto memories they would otherwise have lost. Add neurons, lose memories, remove neurons, keep memories. And then the detail I find most persuasive in this entire literature. Not every animal has infantile amnesia. Guinea pigs don't. Dagus, a small South American rodent, don't. Both are what biologists call precocial. Born at an advanced stage, eyes open, furred, able to walk within hours. Their brains do most of their building before birth, so their rate of postnatal hippocampal neurogenesis is low. Low neurogenesis, no infantile amnesia. The pattern holds across species, and the researchers took the last step. They artificially raised neurogenesis in infant guinea pigs and degas, animals that do not normally have infantile amnesia. They gave it to them. So infantile amnesia isn't a defect, and it isn't a deletion. It is what happens when a brain is still being assembled at speed while it is already in use. The cost of building the machine that will hold your whole life is that it cannot hold the first stretch of it. Now, some of you have been arguing with me this whole time. You have a memory from before you were 2, maybe from a crib or a hospital or a room your family left before you turned 3. It is clear and specific, and people have told you it's impossible, and you know it isn't because you were there. This is the single most common response to this topic, and it deserves better than being waved away. So let's take it seriously in both directions. In 2018, Shazia Akhtar, Lucy Justice, Katrina Morrison, and Martin Conway published a study in Psychological Science on a sample most memory research can only envy. 6,313 people, describing their earliest memory and dating it. The average age of the earliest memory was 3.15 years. But look at the spread. Of the 2,479 first memories they analyzed in detail, close to 40% were dated to age 2 or younger, and 14.1%, 887 memories, were dated to age 1 or younger, below 1, below walking in most cases, below language. The author's interpretation is that many of these are not recollections at all. They are reconstructions. An image assembled later out of a family story, a photograph, a parent's retelling, stitched into something that has the texture of memory, because that is what remembering actually is. Memory is not a video file you play back. It is a rebuild, every time from fragments plus expectation. That interpretation is disputed. A published comment on the paper argues the fictional reading goes too far, and nobody has a way to look inside a specific person's head and certify one memory as genuine and another as constructed. So the fair statement is this: memories dated below age 2 are statistically very likely to contain reconstructed material. And no one can tell you which of yours is which is not the same as saying you're lying or that nothing happened. And there is a second finding that makes the whole picture stranger, from Patricia Bauer and Marina Larkina at Emory, published in 2014. They didn't ask adults to look back. They started at the other end. They recorded 3-year-olds talking with their mothers about real events, a specific trip, a specific day. Then they went back years later and asked those same children what they remembered. Children aged 5, 6, and 7 still remembered 60% or more of those events. Children aged 8 and 9 remembered fewer than 40%. Read that twice because it is the opposite of how everyone assumes this works. The memories were there. 6-year-olds could tell you about their 3rd birthday. It was the 8 and 9-year-olds who had lost it. Age 7 is roughly the inflection point after which forgetting settles into the adult rate. So childhood amnesia is not something that happens to you as a baby. It is something that happens to you later, in primary school quietly, while you are busy with other things. You did not fail to record your early childhood. You were carrying it around at 6, and it drained away. One last piece, and it is the one that makes me most confident that this is about access rather than storage. The boundary is not fixed. It moves depending on how you were raised. Maori adults in New Zealand report the earliest first memories of any group studied in this line of research, around 2.5 years old. Not because Maori hippocampi are different. The explanation researchers, including Harlene Hain and Shelley MacDonald, have given is that Maori family life places unusual weight on elaborate storytelling about a child's own past from very early on, and related work found that a mother's reminiscing style Whether she asks open questions and builds a rich narrative, or just checks facts, predicts how far back her child can reach as a teenager. Being told the story of your day keeps the day reachable. Every retelling is a rehearsal, and a rehearsal is a path back in, which is exactly what you'd predict if the problem is access. So, 3 things nobody has shown. Nobody has shown that a specific memory from your own first year still exists in your head today. The evidence for surviving early memories is in rodents with a laser. The human evidence is that the recording happened, tested over about a minute and a half. Nobody has a way to get such a memory out. There's a popular idea, I've seen it stated confidently, that you can retrieve infant memories by searching your mind emotionally rather than verbally. There is no evidence for that, and the older claim that early memories can be recovered in a therapy room has a long, well-documented history of producing vivid, confident, false recollections. Reactivation in these studies means a fiber optic cable in a mouse's brain. And nobody has shown the reverse either, that your early memories were destroyed. That is the version the internet prefers, and it is not what the data say. What survives from those 3 years is real, though, and it is not nothing. Your first language lives in your mouth. The way you sit with distress, whether the world became a place that reliably came when you cried, was set then. And it is not a memory you can call up. It is a way of being. The reason some people flinch at dogs for no reason they can name is not that the memory is gone. It is that the memory was never the sort of thing you were going to be able to narrate. The event and the recollection of the event are 2 different objects, and only one of them left. That is the honest shape of it. Something in you learned to walk, learned a language, and worked out who was safe, the hardest work you will ever do, and then handed you the results without the receipt. You were there. The record just isn't addressed to you.